We're going to start with comparing functions. Now, we've already talked about slope and y-intercept. Now what we're going to do is we're going to take that information and we're going to put it all together. Okay, so functions can be represented by tables, graphs, equations, or words. We are going to compare two functions represented in different forms by comparing the rate of change, which is the slope, and the initial value, or the y-intercepts. We can talk about which ones are increasing and decreasing at a faster rate to determine which functions have a greater value for a given input. Okay, so here we have the function represented by the table has a rate of change of 4, and the function represented by the graph has a rate of change of 1/2. Therefore, the function that represented by the table has a greater rate of change. So that's all we're doing. We're looking at the slope, or the rate of change, and then the y-intercept to find out which one has a greater. Okay, so I look right here. It says the function m equals 140h, where m is the miles traveled in hours, represented by the distance traveled by the first Japanese high-speed train, the distance traveled by the high-speed train operating in China. Okay, so China is this table, the Chinese high-speed train. So we're going to compare the initial values and the rates of change, then determine how much farther the Chinese train will travel than the Japanese train if you ride each train for 5 hours. Okay. So it says, compare the initial values of the rates of change. Well, first of all, we have to figure out what those are. So if I'm talking about the Japanese, oh, I want to use a different color, sorry. Let's use Japanese. My equation is not that. Is m equals 140h. Okay, so there's nothing added on. So my initial value is 0. My slope is 140. This is my slope. But for the Chinese, I need to look that up. So if I go right here, I will find that that is 217. If I was to go back, now if you really thought about this, you would be able to get this without even thinking about it. That's going up by 217. Well, guys, isn't this a proportional? Because if you haven't gone any time, you haven't gone anywhere. So that would have been proportional anyway. Okay, so it says at 0 hours, no distance has been covered. So for the initial value, they're exactly the same thing. So the initial value for each function is 0. The rate of change for the Japanese train, I'm going to actually switch. For the Japanese train, well, right here, that tells us how fast it's going, 140 miles per hour. For the Chinese train, we already found it to be 217 miles per hour. So the initial values are the same, but the rate of change for the Chinese train. The Chinese train is 217, the Japanese is 140, so it is greater than the rate of the change for the Japanese train. Now, determine how much farther the Chinese train will travel than the Japanese train. Well, first of all, we have to figure it out for 5 hours for both of them. So I would plug it in, replace the hours with 5, and get 700 miles. Okay, so then I come over here. If we're going up by 217 each time, that means I'm adding 217. So that's an 8, that's a 6, that's an 8. I'm adding another 217 to that. That's a 5, that's an 8, 1085. So it wants to know what the difference is. So I would subtract that. And when I subtract these, I get 385 miles. The Chinese train has gone 385 miles farther. And that's what you're going to do on each one of them. So you need to find the slope and the y-intercept for each one of them. So here it says, suppose you want to decide which movie streaming service you should join. Company A charges $1.50 per movie and a startup fee of $5. Per is telling you that that's the slope. So the slope for this is $1.50. The y-intercept, or the starting fee, is 5. So I have sorry, I did not mean to put an M there. That is my equation for that one. Okay, then I look over here and I have company B. So this is going up by 4. This is going up by 2. So that means my slope for this one is 4 over 2, which is 2. Okay, finding the y-intercept for this one is actually pretty easy. If I'm going up by 2's, what plus 2 is going to get me 2? 0 plus 2 is going to get me 2. So what plus 4 is going to get me 8? 4. So my y-intercept is 4. So my equation for this one is y equals 4x. Nope, not 4x. Sorry about that. I was looking at the wrong thing. Is 2x plus 4. Okay, awesome. So now we're supposed to compare. So if I'm comparing the rate of change, I'm going to look at the rates of change. So I'm going to look here and I'm going to look, oopsie daisy, here. Which one has the greater one? Company B does. So company B has a greater rate of change. Then I look at the y-intercept. So I'm going to look at the y-intercept this time. It's 5 here. It's 4 here. So company A has a greater initial value. Okay? Then the next part says, how much more will company B cost than company A if we have 15 movies? So that I'm just going to take my equation, y equals $1.50, x plus 5, and I'm going to plug in 15 because it says 15 movies. So y equals $1.50 times 15 plus 5. Y equals 22.50 plus 5, so y equals $27.50. Then I'm going to take company B, and we have y equals 2x plus 4. I'm going to replace that with 15. I'm going to get 30 plus 4, which is 34. So, how much more does company B cost than company A? So I take 34, I subtract $27.50. I will get $6.50. So company B costs $6.50 more sorry, I've got to move this a little. Renting 15 movies. And that's what you do. So let's come to this one right here. It says Angela and Benjamin have a monthly cell phone bill. Angela's monthly cell phone bill costs 15 cents per minute plus an initial fee of $49. Benjamin's monthly cost is shown right at the graph. So if I did this one, and I went up and over. How far up did it go from 60 to 72? It went up 12. From 0 to 120, it went across 120. So my slope for this would be 12 over 120, which will get me, since we're talking about money, we're going to put it in 10 cents. Okay. And where does it start? It starts at 60. It started right here. Okay. So it says, what's the initial value for Angela's bill? So the initial fee is $49. Oh, I'm going to change colors. Sorry. It's $49. What is the initial for Bill's bill? $60. So Benjamin has a greater initial cost. What is the rate of change for Angela's bill? Angela's bill is 15 cents per minute. What is the rate of change for for Benjamin's bills? It was 10 cents per minute. So Angela pays more money per minute. So then, right here, it wants to know the monthly cost for 200 minutes. So all we would do is plug in 200 into this equation, and that would get me 30 plus 49, that it would get me $79. Now we look at the graph at 200 minutes. So 200 minutes is right here. So if I look straight up, I'm going to get that it cost $80. Okay. So next one. Okay. Says you and your friends go on a canoe trip, river run canoes. Okay, so river run canoes has an initial fee of $10, and then they have $10. Oops, that was ridiculous. $10 per hour. Okay, awesome. The cost of water canoes clear water canoes is in the graph. So if I look at this, let's look at its slope. It went up 4, it went across 2. So that means the slope for this one is going to be 4 over 2, which is 2, and its initial is 0.16. Okay, so let's look at this. Compare. Which one has the bigger rate of change? The bigger rate of change, I'm looking at my rates of change. I should have put per hour. That would have been smart. So, the river run canoes has a greater rate of change. Then let's look at the initial values. The initial values for clear water canoes has a greater initial value. All we're looking at is the y-intercept and the slope. So determine the cost for each company. Okay, so if I came up here, this equation is y equals 10x plus 10. So y equals 10x plus 10. And it's for 4 hours. So I take 10, I multiply it by 4. 10, I get y equals 40 plus 10, I get $50. Then I do it for the second one. Y equals 2x plus 16. So y equals 2x plus 16. I plug in 4. 8 plus 16 equals $24. Determine the cost of each company. There we go. Okay. We're actually going to go to the next section, and that is on page 293, whether it's a linear function or a nonlinear function. So if I look at this, guys, linear means it makes a line. It has a constant rate of change. Okay? Same rate of change the whole time through. Not a line. I don't know what that last thing was. Not a line. Does not have a constant rate of change. Okay, so if I look at this, well, this has two graphs together, or it has two lines together, but this has a negative slope, this has a positive slope. This is nonlinear. It does not have a constant rate of change. Determine whether linear or nonlinear. Again, nonlinear. It does not have a constant rate of change. Okay, so this next one, we have words now. Well, let's think about it. If I have a line, I'm going to come over here maybe. If I have a line, that means it's in the form y equals mx plus b. Okay? As a line, it has to be in y equals x, mx plus b, where y has an exponent of 1 and x has an exponent of 1. Nonlinear are going to be things like this, or this, or this, or this, or this. So, if you see an equation that looks like something like that, that would be a nonlinear. So if I look at this right here, that means it's going to be nonlinear. Okay, that's all we did in that section. The next section is qualitative graphs. And what we're doing is looking at a graph and deciding its story. So we're going to describe its story. So if I'm looking on the x-axis, we're talking about time in seconds. If we're talking about the y-axis, we're talking about percents downloaded. Now, qualitative graphs are graphs used to represent situations that may not have numerical values, or graphs with numerical values included. Okay, so this one doesn't have any numbers. But if I look at this, I can see that we started with, at 0 time, we started with 0 amount downloaded. Then it steadily downloaded, but then here it stalled out. For a couple seconds it stopped. It didn't download for a couple seconds. Then it started downloading again for a few seconds. And then here it stalled out for a little bit. And then it started downloading again. That's our story. So let's look at the next one. Or let's look over here. These are some of the words that we're going to use. Okay, increasing means it goes a positive slope. Constant rate means that you're going to have a line. Decreasing, that means I have a negative slope. Constant rate means that I have a line. No change means I have a horizontal line. That means there's no change going on. This is increasing, but it has a varied rate. This is decreasing, it has a varied rate. Notice how it is curved. Okay, so let's look at this. It says the graph displays the water level in a bathtub. Describe the change in the water level over time. Says the graph demonstrates how the water level changes as time increases. Okay, so let's look at this. Oh, I didn't have any water in my bathtub. I filled up my bathtub. It stayed at the same spot for a while, and then I emptied my bathtub. Okay, so the water level increased at first at a constant rate. For a period of time, there's no change in the water level. Then the water level decreased. And since these were lines, they made sure to say at a constant rate. Okay, so as we look at this, it's talking about sales. Okay, so let's talk about it. Sales increased. Then sales decreased. Then they increased again. Then stayed at the same, then increased again. Okay, something like that. So let's look over here. It helps if I didn't have the answers here already. Sorry about that. So it says Charlie is riding a bike. He speeds up, he rides at a constant rate, then he slows down. Make sure you understand that this says speed. It does not say elevation. So we don't know if he's going uphill, downhill, if he's on a straightaway. It doesn't matter. This is talking about his speed or her speed. Charlie is riding a bike. Speeds up, so his speed gets bigger or higher. Then he stays at a constant rate. His rate doesn't change. It stays exactly the same. Then his rate slows down. Now, did it say he stopped? No, just said he slowed down. Okay, so I'm going to leave it just like that. Okay, let's look at this next one. A school store sells pencils. At the beginning of the year, they sell a lot of pencils. Then the sales drop, and finally the pencils are sold at a steady rate. So, at the beginning of the year, they haven't sold anything at the beginning of the year. They sell a lot of pencils. So, all of a sudden, a lot of pencils were sold. Okay? Then it says the sales dropped. Finally, the pencils are sold at a steady rate. So it's at the same rate. And there you have it. Okay. A tennis ball is dropping on the floor. Now, if you think of a tennis ball, each time it hits the floor, it doesn't go up to that same height. It goes at a lower height each time. Now, when you're throwing, you don't throw from the ground. You throw from up here. So when you throw that ball, it hits the ground and goes back up. Hits the ground and goes back up. something similar to that. Okay? So, oh, it helps if okay, there we go. Picture's already there for you. Okay, determine if the graph is linear or nonlinear. Okay, so is the rate of change of the graph constant? No, it is not. The graph is blank whenever the tennis ball travels up in the air. So when it's going up in the air, when it's going up, it is increasing. Okay? The graph is what when it's coming down? It is decreasing. Okay? Because the distance from the floor is decreasing. Okay. It also helps if I didn't put the answers for this one. Okay, let's change colors. We'll go here. It says a person is riding the bike, slowly decreases their speed, then they quickly speed up. Finally, they maintain a constant speed for a period of time. First of all, I need to draw my graph. Okay, and we're talking about time. And we're talking about, it doesn't say what kind of time. And then it's talking about the speed and how fast it's going. So a person slowly decreases, A person riding a bicycle slowly decreases their speed. So we must have been going at some rate at some point in time. So, come on, draw. So we're slowly decreasing. That was really horrible. So we're going to do, Kimberly, seriously. We're slowly decreasing. Then they quickly speed up. And finally, they maintain a speed for a period of time. Okay? Determine if it is linear or nonlinear. It's nonlinear. Okay? So this was decreasing. This was increasing. And this is no change. Okay. So on this one, it says, actually I want to do this one right here. Julian is riding his horse. The horse's speed increases at a constant rate for 2 minutes until the speed reaches 10 miles per hour. Then it increases at a rate of 1 minute, varied rate for 1 minute until it reaches a speed of 20 miles per hour. Finally, the horse decreases its speed at a constant rate for 3 minutes. So, I'm going to draw this. Okay, so down here we have time, and we have 2 minutes plus 1 minute plus 3 minutes, so I need to get at least 1, 2, 3, 4, 5, 6, 7 on there. And then we went up to 20 miles per hour, so this is speed. Oh, this is miles per hour. This is hours. Okay, so I need to do, I'm going to do 2, 4, 6, 8, 10, 12, 14, 16, 8, not 80, 18, 20, and I'll go up to 22 just to be. Okay, so it says right here, 2 minutes until it reaches 10 miles per hour. And it is a constant rate. Okay, so 2 is 10 miles. So 10 miles per hour. So I'm going to do a constant rate. So that means I have an actual line to write there. Then it says we add on 1 more minute. Okay, we add on 1 more minute. So if we're at 2, that means we come over to 3. So at 3, we're going 20 miles. So 3 20 miles. But it says on this, it doesn't say a constant rate, it says a varied. So we're going to kind of curve that. Okay? And then it says, finally, the horse decreases its speed at a constant rate for 3 minutes. So we're at 3. We go 3 more minutes until it comes to a stop. And it's a constant rate. So we're going to come down here because he's going to stop. And there we have it.